What's up, you guys? In this video, we're going to be talking about exponents and radicals. We're going to look at some weird parent functions, really just weird functions in general, but we've already talked about them, so it's going to be nothing new. In this unit to come, you see an exponent right there, so we're going to be dealing with exponents all unit long. We're going to introduce something called a logarithm, which is also pretty cool. Other than that, let's just jump into it. So this is the form that you will see it on Apex. It's going to be a times x plus k. Remember, this moves it the opposite direction. It's with the x. So if this k is negative, then it's going to move it to the right. If this k is positive, then it's going to move it to the left, move it in the negative direction. So just don't forget, anything with the x is going to do the opposite of what you see. 1 over n, I have a little thing here about n. Remember 1 over, like if we had x, the square root of x, that was the same thing as x to the 1 over 2. We know our square root graph looks something like that. If we had the cube root, we also learned about the cube root graph, which was x to the 1/3, which looks something like that. Right? We've learned about both of these functions to this point. So if n is an even number, it'll be similar to our square root. So it'll look something-ish like that. It could be moved around. Different things can happen, but it'll look something like that top one up there. If n is an odd number, it'll be similar to a cube root. So it'll look something like that. So here are all your reminders. I don't care. I'm not resetting my computer. Here are all your reminders. A affects the graph's vertical stretch. So like if this is 2, it's going to multiply the y values by 2. So it's going to like stretch it out vertically. K will move the graph left or right, like we talked about, and C will move the graph up or down. So like if C is positive, then it's going to move up so over many units, and if C is negative, it'll move down so over many units. So just don't forget that those affect those things. If the A is negative, so if the whole function is negative, it reflects it over the x-axis, so it kind of does that with it. All right, other than that, let's just see how we kind of graph these things, and you guys should be good to go. This isn't a very long one. All right, so sketch the graph. I'm going to move out just a little bit. Sketch the graph and state the domain and range. So I'm not looking for a perfect graph. So with this, the first thing I notice is it's 1 over 5. So that tells me I'm going to have something similar to a cube root or something like that. So now that minus 3 on the inside, it's with the x's, so it's going to move everything to the right 3. That minus 4 on the outside will move everything down 4. So if I take this graph, I move it 1, 2, 3 to the right, down 1, 2, 3, 4. Then all I really care about is that it's going to look something like a cube root graph. That's really all that we're going to be hitting on this one. Should be pretty easy. It's just looking for the basic shape of the function, not like exact points, just kind of sort of what it looks like. All right, so now for stating the domain and range. The domain on this one is going left and right forever, so we would have -infinity to infinity. For the range, it is also going up and down forever, so we also have -infinity to infinity. That's it. All right, moving on. Here, again, first thing I look at is the exponent. So look at the exponent. The exponent is 4, so I know I'm going to have a basic parent function, something like that. So now I have to think about all the effects on the graph. So I'm going to multiply the y's by -2. Y's by -2. So that negative on the outside, that's going to multiply the y's by -2, so it'll flip it over the x-axis. Now this plus 3 is going to move it left 3. Remember, it does the opposite of what it has on the inside. And then the plus 1 moves everything up 1. So if I start with my parent function looking like that, y's by 2 is going to stretch out my parent graph. Right? Come on, pen. There we go. So it'll look more stretched out in the y direction. Then I can flip it over the x-axis. So once I flip it over the x-axis, it'll look something like that. And then move everything left 3 and up 1. So 1, 2, 3, up 1. So it'll have that point. And then about a shape something like that. That's really all we're trying to get at with this, is about how would it look. So now for the domain, the lowest possible value that I have here is this -3. So that is included. So I have everything from -3 and on. So -3 to infinity. For the range, I have the lowest value I have, it's going down forever, so the lowest value is negative infinity, and then to the next highest value would be to positive 1 right here on the y-axis. That's my highest y value that I have for any point. So I have 1, it is included, so I put a bracket around it. That's it. All right. Telling you, really short section. Now the pups are going to come. They heard me doing the squeaky thing. What are you doing, Corey? You lumbering in here? Chunky dog. She's like a little sausage. Let's show you. Sausage dog. Sausage dog. What are you going to do about it? You going to try to eat me because you're hungry, you little sausage? You're a good pup. All right. Sorry. Distractions. I love dogs. Now they're going to fight. I have 2 dogs. Hank, you want to be in the video? Yeah, there's Hank. He's cute, but he's scared. Yeah. He doesn't like things. He gets real shaky if there's thunder. All right, anyways. So 1 over 9. So the 9 tells me that I have a cube root-ish, right? It's an odd power. So it kind of ish looks like a cube root. Now this negative 1/2 on the outside, that's going to multiply the y's by negative 1/2. So y's by negative 1/2. So it'll reflect it over the x-axis, and it's also going to vertically compress, right? 1/2 is taking half of it. So we are compressing the graph down, and then I'll move it to the right 5. So let's see, right? 1, 2, 3, 4, 5. And then I have it reflected. So instead of going this direction, it's going to reflect and go the opposite direction. And then notice I drew it pretty skinny because it should be vertically compressed somewhat. I'm not going to draw it way far out there. All right, so now for the domain, negative infinity to infinity, going left and right forever. For the range, up and down forever. Even though it's really compressed, it's still going up and down forever. Questions? No, I'm just kidding. You can't really ask a question right now. All right. Anyways, please, 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 if you do have a question, though, just let me know. Bring on your questions. I look forward to answering them. I'll talk to you soon. All right. Bye.